All right, so in this video, we're going to talk about a new type of graph called the regular box plot. Regular box plots basically just show the 5-number summary graphically. So it's easiest to just kind of show you by example. We're going to make a regular box plot of our FICO scores from a previous example. So we have these, what was it, 11, 1, 2, 3, 4, 5, 6, 7, 12. We have these 12 FICO scores. And previously we had found the 5-number summary as given here. So we've got the min, we've got Q1, we've got the median, we've got Q3, and we've got the max. Okay, and so basically we're going to draw this. So we're going to put ourselves a little scale here. Our data goes from a little bit above 650. So I'm going to go by 550s. So we've got 700, 750, 800. I should have made this a little bit bigger. Let's make it a little bit bigger. So we want our scale to fill up our whole graph area. Now you're not going to make these by hand all that often. That might be better. So 700, 750, 800, 850. That'll work. Okay. And so what we're going to do is we're going to mark the minimum at 664. So that's maybe about here. I'm eyeballing it. I'm going to mark Q1 at 706. That's about here. I'm going to mark our median at 766. It's maybe about here. Our Q3 at 810. We're going to mark it here. And our max at 836, so maybe about here. Now what we're going to do, so I'm going to label these. Normally you wouldn't label them. And what we're going to do is we're going to connect the Q3 and the Q1 to form a box, a rectangle. That's why this is called a box plot. And then we're going to extend what are called whiskers from the quartiles to the min and the max. So this is called a whisker, like on a cat. Okay, so each part of this, we're able to see how spread out each quarter of our data, each quartile of our data is. So this is good for comparing different groups on the same scale, because it makes it really easy to compare medians, to compare spread through interquartile range, and also to make some comparisons about skewness. Let me give you some examples from in Minitab in just a minute. But I wanted to show you a little bit first about how we can look at skewness in box plots. So up here at the top, you can see here that our upper, and this is oriented horizontally instead of vertically, but you can see that the upper whisker is much longer than the lower whisker, right? Than the left whisker. And so that tells you that it's lopsided, that it's skewed to the right. We also see that it's longer, greater distance from the median to Q3 than it is from the median to Q1. In our other box plot to the left, or to the right here, we see the opposite, right? We see that this whisker here is much longer than the whisker on the right, right? And then we see the same sort of lopsidedness between our quartiles and the median. So we can tell pretty easily that it's skewed to the left. So below that, we have two histograms, one for disease X, which is the distribution that looks symmetric roughly. And then we've got multiple myeloma. This is how many years from diagnosis until death. And you can tell that that's very much right skewed, right, from the histogram. And so when we look at the box plots, we see basically the same thing. We see that the distance from the median to the max and the median to the min is about the same. The distance from the median to the quartiles is about the same. And that tells you that it's roughly symmetric. The multiple myeloma, on the other hand, of course, we have very much our top quarter of the data is very spread out, is very skewed, and we see that in the differences between the two whiskers. So we're going to look at some box plots in Minitab. When we're comparing box plots, we want to compare medians. This median's higher, this median's lower. We want to compare spread. So we want to say, this one has a smaller inner quartile range, so it's less variable, so on. We want to compare outliers, but this is not going to be in regular box plots. This is going to be what's called modified box plots, which we'll talk about in the next video. And then skewness, like I said. So for example, we can use box plots to compare several baseball players and answer the question, well, who was the most consistent baseball player? And consistent here really means who has the least variability, the least spread, all right, the smallest inner quartile range. So we'll look at a few things in the class data. We'll look at the cell numbers by gender and whatnot. But before I jump there, we'll look at the last slide here, because this is just a reminder for you guys on how to make box plots in Minitab. It does depend on how you have your data set up. Most of the time, though, you're going to have your quantitative variable and then a categorical variable that you want to split your data up over. And so we'll do that. We can compare number of children by whether or not you're married, and then how many cell phone numbers in your cell phone by your gender. So I've got Minitab pulled up here, and we want to make a box plot. We're going to go to graph, and you can find box plot in the list here. All right, and we're doing box plot. If you just want to plot one thing, you can do simple, right? So we can go okay and say, okay, I want to make a box plot of the number of children people have. So we'll select that variable, and we'll just leave everything else alone. Now, Minitab does not make regular box plots, it makes modified box plots. So we do have our outliers showing on here. And again, that's in the next video. But let's look at number of children by whether or not you're married. So in that case, we went to go make a box plot, and we're doing with groups, because we have groups here. We have married and unmarried, right? So if children is our graph variable, if I pick the right one, nope, children, there we go. And when we click categorical variables, we have the option for married, all right? And you can do up to 4, but that just gets complicated, all right? So we're going to go okay. And this is going to put two plots side by side on the same scale. Now, in our unmarried box plot's a little odd. I'll talk about that in a minute, but our married people, you can see our quartiles, Q1 here at about 1.5, a quarter actually, according to Minitab, and our Q3 at 2, and the median happens to also be 2. All right, so that says we had a lot of married students that have 2 kids. So here our median and our Q3 are lying right on top of each other. Over here in our unmarried, of course, most of our unmarried students have no kids. And so our first quarter, our min, our Q1, our median, and our Q3 are all 0. And so we have a lot of very concentrated data here. We could look at histograms the same way. Let's look at histogram with groups. And we can do our graph variable of children and our categorical variable of married. And I want these on separate graphs with the same X. That'll make things easy. And when this will, oh no, it didn't do it in separate graphs, but you can see our blue is our unmarried. So we have lots of unmarried students with no kids, which is why almost all of our data is here. And we're seeing that in the box plot. So let's look at one that's a little bit better. That is, I think, number of cell numbers by gender. So is there a difference in how many contacts you have in your phone based on whether or not you're male or female? So we've gone to graph, box plots, and then we're going to pick groups again. And we're going to pick cell numbers for our graph variable, and we're going to use gender for our categorical variable. And so this gives us a little bit better. Again, we've got our outliers on here that are not in a regular box plot. They're in a modified box plot, but the idea is the same. So we can look at the females and say on average, or typically rather, I should say, females have more contacts in their cell phones than males, because the median here is about 100. Let's see, if we hover over it, we're going to see it's exactly 103 versus the men, which is looks lower. It's about 47 apparently. We can also say that the interquartile range for the females is a good bit bigger. You can visually see that that's bigger than for males, and that the range, if we don't count outliers, is bigger for the females than for the males. And both of these distributions are skewed to the right, to the larger numbers, because our upper whiskers are much larger than our lower whiskers. All right, so those are the sort of comparisons you can make. So you can say, in general, women have more contacts in their cell phones, and they're a little but men are a little more consistent in the number of contacts they have across the population. All right, so you can play with those on your own, but that is it for this video. Thank you.